that's one thing that you can have. Number two is that dp of omega is 0, which is closed. That's the definition of what we're looking for. And number three is that the integral of p of omega equals the topological invariant over any compact, provided the manifold is compact. Which means it's bounded. It's a two-form. Omega would be a two-form in any dimension. There may be, I think people have thought about generalizations going beyond that, but you run it, it's trickier. It's trickier. There has been some thought given to that. So, just to flesh this out a bit more, suppose I define omega t as t times omega 1 minus omega 0 plus that, where t ranges from 0 to 1. So the idea is this is some form, and I interpolate between omega 1 and omega 0, and they are not age related. Omega 1 does not necessarily equal that. In other words, this is just, I'm imagining in form space interpolating between one kind of one form over here, different kind of one form over there, and we see what happens. Well, omega t will be d omega t plus omega t squared, and one can show, which I'm running out of time, so I won't show, but you can show that d by dt of t of omega t is m times so if p of omega is equal to the symmetry of omega to the m, say, then this turns out to be d of the symmetry of omega 1 minus omega 0 times omega t to the m minus 1. And from that, you can show that the integral of p of omega 1 is equal to the integral over the manifold of p of omega 0. You do that by integrating both sides with respect to t, comma there. You do that by integrating both sides of this equation with respect to t. These are all functions of t in here when you put them in, and you can show that you also have to use that dp is equal to 0. So it's in this sense that at least this symmetry is an example of a polynomial that would indeed be closed and topologically invariant, form a topology on the manifold. I guess I'm pretty much out of time. There is I probably should continue this for a little bit on Monday just to finish it off. But the result of the index theorem, let me just write down the answer, but I think to be fair, you will have to invest